In this video, we're going to use VSEPR theory to determine the shape of any kind of particular molecule. So before we get into some examples, let's first kind of look at how we would go about figuring out the shape of a molecule. The very first step we need to do is we need to draw the Lewis structure for the molecule. So we have to have a really good sound understanding of how to draw different Lewis structures. Once we're there, we're going to count the number of bonding and lone pair or non-bonding electrons about a central atom. So we have to have our central atom and then figure out how many bonds we have and how many non-bonding pairs we have. And then finally, we're going to use VSEPR theory to predict the shape of the molecule and draw the molecule in that particular shape. So let's take a look at a few examples. Before we get into that, though, this is just a little bit fun. I kind of like this because this is some VSEPR yoga. You can try it on your own if you want. Okay, all jokes aside, let's take a look at some examples. So let's look at first the shape of sulfur 4 chloride. So when we're given this, we first need to know, okay, sulfur 4 chloride is SCl4. Now going through and doing our Lewis structure, we first need to figure out how many electrons are in this structure. So sulfur has 6. Each of our chlorines has 7. So that's 28. Okay, adding that together would be 34 electrons. If you're not quite sure how to do that, go back to my Lewis structures video and take a look at that one. All right, from here, we're going to do central atom. We're going to put our 4 chlorines around it. Okay. We're going to fill up valence shells of the chlorines. And once we've done that and count up all the electrons, there are 32 here. We need 34, so we're going to put our last pair on our central atom. So now what we need to do is we need to look at our sulfur, because our sulfur is our central atom, and look at how many bonds and how many non-bonding pairs. So there's 1, 2, 3, 4 bonding pairs, and there's 1 non-bonding pair of electrons. And then we're like, we can look at that and go, okay, there are 5 things attached. So 5 is based off of a trigonal bipyramidal shape, with 1 less means that this will be our seesaw shape. So if we were asked to draw this shape, then we would do our sulfur here. We would do 1 chlorine going up, 1 chlorine going down, 1 coming out of the page with a wedge, the other one going back with a dash, and then our lone pair of electrons here. Okay, VSEPR shapes do not need all of the valence or all of the lone pairs of electrons on the outer elements. We're just really showing the central atom, we're showing the shape, and then we're showing what's attached to it. All right, so that's it for sulfur 4 chloride. Let's look at another example. This one is for sulfur 6 chloride. So kind of very similar, all right? So if we're going to take SCl6, sulfur has 6 electrons. Each of the chlorine have 7, so that's 42, which means we should have 48 electrons in our Lewis structure. And let's go central atom. We'll put our 6 around that sulfur, fill the valence shells of the outer ones. Okay, so that's all full. And if we count them up now, there are 48 electrons here, so our Lewis structure is correct. Now, if we go through and we take a look and we do our analysis again, we have our central atom sulfur. There are 6 bonds to sulfur, 1 to each of the chlorines, and there are no bonding pairs. So this is based off of an octahedral shape, and because it's 6 bonding, 0 non-bonding pairs, its VSEPR shape or molecular geometry is also octahedral. If we were to draw this one, its VSEPR shape then, Just going to do 1 chlorine up, 1 chlorine down, and then we draw the ones in the middle here. Okay, we really want to make sure we're stressing angles because that's kind of the whole point of a VSEPR diagram, is to really stress what the angles would look like and what the three-dimensional shape looks like. Our last question here, we're looking at the VSEPR shape of pH3, or the molecular shape of pH3, and we're going to name the shape. So again, we got to start with our Lewis structure. For phosphorus, it has 5 electrons. Each of the hydrogens has 1, so that's 3 total. So we should have 8 electrons in our Lewis structure. So let's go P, then we'll add an H for each. Remember, hydrogens only can take 2 electrons, so those valences are full. If we look at that, that's 6 electrons, so a lone pair has to go on the phosphorus. Now, if we come back through and look at our central atom phosphorus, it has 3 bonds and it has 1 non-bonding pair. So 3 bonding pairs and 1 non-bonding pair. Okay, so this shape is based off of a tetrahedral shape, but because we have 1 non-bonding pair, this is going to be trigonal pyramidal. All right, and so if we were to draw this one, we're going to draw a P. We're going to draw a lone pair of electrons on the top, and then the ones in our triangle pyramid, we're going to have a wedge, a dash here, and then a line. Okay. If we were to ask for bond angles, we could also point out that these ones are 107 degrees. That's it for them for this video. We'll see you in the next one.